Hello everyone. Today we will study concept of control strips. First, basic concepts. The printing quality measurement and control strip is generally defined by the following parts. The first is the control segment, which is used for printing inspection. It is a planar icon composed of one or more graphic units. According to the technological process, it can be divided into the plate-making control segment and the printing control segment. The control segment can be arranged in single color or multiple colors for use. The second part is the continuous tone control segment. The planar control block is a continuous structure of infinite density. The continuous tone control part can have a certain density, a tone without change or a gradual change. The continuous tone control block with step density changes is what we call the continuous tone step scale. The step scale mentioned here is exactly this. The solid control block is the one with the highest optical density, or the lowest brightness. When it comes to multicolor printing and image inspection, it can be divided into the solid block for single printing and the overprint solid block. The function of the overprint solid block is to check the overprinting ability and the overprinting effect. The fourth is the blank control block, which is a control block with the lowest optical density, defined in the process or the highest brightness. Fifth, in terms of the screen tone control part, it is a control block with different dot structures. It includes image components of the same type. The screen tone control segment should have a unified screen tone gradation, or a gradually changing gradation value. The screen tone value with a step or step change is what we call the dot step scale. Sixth, the original dot control block is a screen tone control block composed of a group of circular dots. Seventh, the gray balance control block is a control block used to detect the dots for proofing and printing gray balance. It is composed of the dots of the three primary colors according to the proportion of gray balance. Eighth, the line control block is a control block composed of lines according to the different widths, distances, and angles of the lines. Different lines can be arranged on the control block. Ninth, the micro line control block is a control block composed of fine lines. It has different widths in its arrangement. It is a fine line and can be used for visual evaluation. 10th, the inspection marks are the marks and side marks used for determining the position and inspection. For example, the commonly used registration marks, crease lines, and cutting marks all belong to the inspection marks. These are used to assist our printing or post-press processing. The measurement and control strip is a control block arranged in one dimension, composed of several known areas, test units, and signal blocks. It provides a tool for visually inspecting, measuring, calculating, appraising, and using to check the quality of printed matter. Second, the use and purpose of the printing quality measurement and control strip. The application range of the printing quality measurement and control strip includes screen tone printing and non-screen printing, single color and multi-color printing, the production of offset printing plates, proofing, printing, and image inspection, gravure printing, letterpress printing, including our flexographic printing, and screen printing can all be used as a reference, although there are specific rules for image reproduction. Since the tones of all images are random and the highlights, midtones and shadows of each image are arbitrarily distributed, the limitations of visual judgment are very large. In order to control and improve the reproduction quality of printed matter, by using a planar test icon composed of known specific areas, and graphic units of different geometric shapes, and cooperating with the instrument test of printing quality and visual judgment, we can inspect and monitor the quality of graphic information transfer during copying, plate making, proofing, and printing, so as to achieve the purpose of detecting and controlling the reproduction of printed matter. Using the printing quality measurement and control strip can realize the standardized management and operation of the printing process. Therefore, the use of the printing quality measurement and control strip can achieve the following purposes. First, control the quality of plate making. Second, ensure the uniformity of the quality of printed matter. And control the quality deviation value within the allowable range. Third, reduce the difference between proofing and formal printing, which are the main purposes of our use of the measurement and control strip. Third, the classification of the printing quality measurement and control strip. What are the types of the measurement and control strip? Let's take a look. The control strip is an important medium for implementing digital measurement and control of printing quality. In English, the measurement and control strip is called concentrate. It is a testing tool obtained by using precise technology to make geometric figures such as dots, lines, and solids on a film or an electronic document. It should be noted here, in the past, our measurement and control strip was automatically made on the film through the plate making method. Now, because we have some digital means, we can use some software, such as Photoshop, Adobe InDesign, etc., to make it into an electronic file, support the electronic version of the test strip, and directly put it in the document and make it together through the CDP publishing, without the need for the previous film or film. So now the control strip is mainly stored electronically. It is composed of many test areas, test blocks, and test segments with different functions, and is used to judge and control the quality of graphic information transfer during plate copying, plate making, proofing, and printing. According to the grade of printing quality information provided by the printing quality measurement and control strip, we can divide it into two categories: signal strip and test strip, or measurement and control strip. 1. Signal strip. The signal strip is mainly used for visual evaluation, and its function is relatively single. It can only reflect the appearance quality information of printed matter. The signal strip is composed of several signal patches. At the same time, it can promptly reflect the changes of dots during printing, such as enlargement and reduction, axial ghosting or circumferential ghosting, registration accuracy, as well as insufficient or excessive exposure during plate making, the resolution of the printing plate, etc. It provides an objective standard for the control and management of printing quality. The use of the signal strip has the following specific characteristics. First, it can be observed with an ordinary magnifying glass or the naked eye, and at the same time, it can promptly detect the quality problems of printed matter, without the need for special instruments or equipment. Second, the use of the printing signal strip is convenient and easy to master. Its structure is relatively simple, and the application cost is relatively low. Third, the signal strip can only provide information qualitatively, so it is a qualitative mechanism. It can only provide the quality information of printed matter, and cannot provide accurate quality index data. 2. Test strip. The test strip is a tool for controlling the indicators of printed matter, composed of various geometric figures, with known characteristic areas such as dots, lines, and solids. The test strip not only has the function of the signal strip, but also can be observed through some special instruments and equipment, or a high-power magnifying glass with scales. We can observe through these tools. At the same time, with the addition of a color densitometer with a polarized optical device and a spectrophotometer device, we can measure on specific units, and the obtained data can be calculated through a special formula to obtain the quality index data of printed matter. It is used for the evaluation, adjustment, and data storage of printing quality. The test strip is suitable for the measurement, evaluation, and control of the printing quality of high-grade products. 3. Measurement and control strip. If the visual evaluation and test units of the signal strip and the test strip are combined into a multifunctional control tool, we call it a measurement and control strip. It is equivalent to a combination of the above two. According to different printing methods and tasks, different control blocks can be selected for the printing quality measurement and control strip and pieced together into a control strip or a control segment. The measurement and control block on the measurement and control strip or the control segment generally has a size of 6 mm x 6 mm and should not be smaller than 5 mm times 5 mm. This is the minimum size specified by the aperture of the instrument for measurement, which is also determined by the measurement aperture. For example, for the printing quality measurement and control strip used in multi-color printing, the control blocks are arranged one after another in a repeated manner. The structure of the control block includes solid cyan, solid magenta, solid yellow, solid black, micro line adjustment block, deformation or ghosting block. Of course, some dot blocks, gray balance control blocks, etc., can also be added and arranged repeatedly. Fourth, the control principle of the printing quality measurement and control strip. There are many types of printing quality control strips, but the measurement and control principles are basically the same. Summarized, they mainly include the following points. The first is that the increase in the dot area is proportional to the total length of the dot edge. According to the dot gain theory in geometry, the increase in the dot area is caused by the uniform outward expansion of the edge part of the dot. As the screen ruling increases, the total length of the dot edge also increases. The coarser the screen ruling, the fewer the dots per unit area. The larger the area of a single dot, and the shorter the total length of the dot edge. Therefore, the resulting dot gain value is smaller. On the contrary, if the screen ruling is finer, the number of dots per unit area is larger. The area of a single dot is smaller. The total length of the dot edge is longer, and the resulting dot gain value is larger. The higher the integrated density value, the greater the difficulty of printing. The lengths of the dot edges with different screen rulings are different, although there are slight differences among square, circular, chain-shaped, and oval dots. The rules are the same. Therefore, the screen ruling should be set reasonably according to the needs of the product. And it is not that the finer the better. If it is a large format poster, it is suitable for printing with coarser screen ruling. The screen ruling should be lower. It is not that the higher the screen ruling, the better the product quality. On the contrary, if you set the screen ruling of the product quality to 300 lines, it is not suitable for printing. The Brunner measurement and control strip uses the different increments of fine screens and coarse screens to measure and control the dot gain during printing. The areas of the fine and coarse dots are equal in total. Here, the screen ruling of the fine screen is 60 lines per centimeters, and the coarse screen block is 10 lines per centimeters. The ratio of the total edge lengths of the dots of the two is 6:1. That is to say, the circumference of a fine dot is 1/6 of that of a coarse dot. So the dot gain is also 6 times larger. Under the same conditions, the dot gain value of the fine dots is relatively large, and the integrated density is high. Therefore, we take the density of the coarse dot control block as the reference. Take the difference between the coarse and fine dots, and calculate the dot gain value of the printed dots. This simple, fast, and accurate method is suitable for the on-site management and quality monitoring of printing production. The second is to use geometric figures with equal areas and opposite positive and negative to measure and control the transfer and change of dots. The reproduction of the screen tone image is to control the transfer of the ratio between the dot area and the blank area by using the known fact that the positive and negative areas are equal. When a signal of unequal areas is found during the implementation process, the deviation in the plate making and printing processes can be controlled and adjusted. For example, in the fine screen block of the Brunner measurement and control strip, there are equal width crease lines and the structure of positive and negative dots. In the plate making process, taking the positive PS plate as an example, if there is excessive exposure and excessive development, the phenomenon of thinner lines and smaller dots will occur. On the contrary, the lines will become thicker and the dots will become larger, reflecting a state of unequal positive and negative areas. In normal plate making, the thinner the equal width positive lines are, the slightly smaller the dots of equal area are. under the premise of correct plate making and suitable printing properties. When the ink supply and printing pressure are relatively large, the phenomena of thicker lines, larger dots, smaller negative dots, and darker image tones will also occur. On the contrary, the lines will be relatively thinner, the dots will be relatively smaller, the image tones will be lighter, and the smallest dots will be lost. The third is that when the radial graphic changes, the change of the center of the circle is obviously larger than that of the edge. The center of the star target signal strip is a very small white dot, composed of 36 black and white equal radial lines. The graphic can also be made by ourselves, and can be made uniformly with AI. When the number of radial lines increases by 1 unit, the center of the star target increases by 11.5 units. And when the opposite vertices are connected, it is twice as much, equivalent to 23 units. That is, it is equivalent to being magnified about 23 times such an effect. Fourth, use equal width or unequal width crease lines to measure and control the changes in the horizontal and vertical directions. During the printing process, when the transmission, swing and rolling of the printing press are not synchronized, or there is vibration, it can be judged and adjusted according to the situation on the signal strip. The slur section of the JTEF (GAIF) signal strip is composed of equal width horizontal and vertical lines, meaning sliding ghosting, and characters will be displayed in this section. The Brunner measurement and control strip uses the equal width crease lines at the 4 corners of the fine screen block to measure and control the changes in the horizontal and vertical directions. Fifth, use concentric circles with equal distances to measure and control the changes in any direction, under the action of the conforming conditions and normal pressure. The lines of the concentric circles only have the change in thickness and no change in direction when the direction is transferred during the printing process. For example, when the position changes, the lines will become thicker along the moving direction and even overlap. At this time, we can adjust the equipment through this reaction. Sixth, provide some unit graphics for testing. The changes of images are infinite. Theoretically speaking, all images have highlights, midtones, and shadows. But most images are not obvious, which brings difficulties to the test. Therefore, the measurement and control strip provides these testing functions. This concludes today's lesson.